Okay, so this video is super important. If you don't get it the first time that you watch the video, watch it again, because it's super important that you understand this this kind of definition of types of variables, because this will define how we are going to analyze the data, and that's the next lecture. But if you don't understand this, it's going to be very difficult, the next part. So please make sure that you understand this. So as I said, a variable, here we have the definition, is a characteristic of a phenomenon that can be observed and measured. And so measure is very important. So we have different types of variables according to how we measure. This is on the measure dimension. So how we measure is going to define these 4 groups of variables. So that's the first thing. It's only about measuring. Okay, so this slide is all about measuring. And let me start with I will start from the right. So with the nominal variables, because in a nominal variable, you are representing something where it doesn't really matter, like it doesn't really matter the number that you assign to that variable. Let me give you an example. I'll try to not confuse you, but if you tell me that I am number 1 and my friend Juan is number 2 and my other friend Jose is number 3, do you assume that because I am number 1, I am the best? We need to have more information for that, right? So if I tell you that 1, 2, and 3 is a nominal variable, then it doesn't matter. If I am number 1, it doesn't mean that I am the best. It's just that I am number 1. That's like my ID number. Or if you saw the Squid Game, do you remember they had numbers in their jacket or shirt? I think like the old guy had 001. So in that case, I think the numbers didn't represent anything. I think it's a bit similar to your personal number, that the personal number tells it's related to your date birth. But I don't know if you have an ID number where it's just a number, like if your ID number is 548 and your friend's number is 890, it doesn't mean anything. It's just that you have a different ID number. So a nominal variable is like that. It's a variable where if one is 1, the other is 2, the other is 3, it doesn't give you any more information. It just shows you that there are different groups or different things. So 1, 2, and 3 are just different things, but it doesn't matter if one is good. It's not like that. So this is nominal variables. And an example is the gender that especially in the traditional view, that we sometimes assume that 1 is male, 0 is female, or sometimes 2 is female. It doesn't matter that female is twice as good as men. No, it's not like that. It's just that you want to differentiate between 1 and 2. And you need to be very careful, because when you do the analysis mathematically, there are tools that work well with this, and other tools will get very confused, because if you use a method to calculate that focuses on, we're going to talk about that, on scale variables, and you use this 0 and 1, then that method is going to assume that male is good or something like that, and it will give you a wrong result. So make sure that you understand what is a nominal variable. And when we do the analysis, I will show you how to treat nominal variables and how to analyze nominal variables and not make the mistake of analyzing them incorrectly. So first part, nominal variables. Make sure that you understand what is a nominal variable. Then the next type of variable, based on how we measure it, is ordinal variables, or we sometimes also call them, let me write in here, ranks. I think maybe a ranking system might sound better, but it is kind of the same thing. An ordinal variable is like a rank. Now, if I tell you, I am number 1 and I am the oldest of my friends. I am 1 because I am the oldest. Then Juan is the second oldest, so he's number 2. And then my friend Jose is the number 3, the third oldest, so he's number 3. So now that you have a bit more of information, I am telling you that now it matters, right? My number 1 it means that I am the oldest, number one, according to elderly, or how old I am. And number two is Juan, number three is Jose. So now that is important. But this ordinal thing is also important because I am one, the other is two, and there is three. But that doesn't mean that Juan is twice as young as me and that Jose is 3 times younger than me. No, it's not like that. It's just that maybe I am 1 day older than Juan and Juan is 10 years older than Jose, but the rank is only 1, 2, and 3. It doesn't, maybe me and Juan were almost the same, right? But Jose is very young. So that is an ordinal variable where you only know the order, like the order is important, 1, 2, 3, 4, 5 is important, but it doesn't mean that the difference between 1 and 2 and 3 is the same. So because of that, we also need to be careful on how to analyze this type of data. But for today, for this video, you should only focus on understanding what is an ordinal variable. Okay, so in nominal, it doesn't say anything. The only thing that it says that I am 1, that Juan is 2 is that we are different. That's the only thing. Then in ordinal variables, it means that I am the oldest, that Juan is the second oldest. And now let's move to ratio and interval variables. So ratio and interval. These two variables are also called scale variables, right? Like scale. Because these two variables, ratio and interval variables, actually tell you how much difference is between one thing and the other. So let me tell you an example, the same example with age. So if I tell you my age is actually a scale variable because I can tell you, I can even tell you how many days old I am. I don't know. So I will tell you that I am 32 years old. So 32 years old, that's me. And then Juan is 31 years old. And Jose is 16 years old. Okay, so that's a scale variable because that number tells me that I am twice as old as Jose and I am only 1 year older than Juan. Yeah, so this is a scale variable when the data gives you information of how, in this case, older I am or the observation is compared to other observations. And the difference between ratio and interval, and this is kind of a spoiler, but in the software that we are going to use to analyze the data, they use the scale variable and not really ratio and interval. So as long as you understand what scale variable, that's good. But in theory, you need to understand the differences of both. The difference between scale and interval is that in the ratio the difference between ratio and interval, in the ratio interval, you actually have an absolute 0. So age is a ratio variable, right? That's a good example because there is a 0 that represents the absence of that thing. So 0 years old means that you don't have, you are not even 1 year old, right? And you can't have minus years old, right? For age, you can't have -1. It's kind of a weird concept, but I think you can't have. So you can have negative and 0 represents the absence of that thing. Other interesting examples are like altitude. Altitude is also a ratio because if you are at sea level, that means 0. So you are 0 altitude. In this case, you actually have negative numbers. You can be below the sea level. So that's also interesting. But the point is that at 0, you have absence of altitude, no altitude at all. For like another example is time. Maybe like in time, if you are recording the time, for example, for a car or like a runner, then 0 means that 0 time, absence of time. And then from there, you can have like 50 seconds, like the first place ended up in 50 seconds and the second place in 52 seconds. So that will be ratio variable because 0 means the absence of time. And then the differences between the observations actually tell you how faster one person was compared to the others. And in interval, the difference with ratio is that in interval, you don't have the 0 point, right? So for example, temperature in Celsius is a good example because 0 degrees doesn't mean that there is absence of temperature, right? 0 degrees is just something like a scale, right? Like I have friends who used to tell me like it's 0, so not cold, not hot. But that's a way to look at it. But in the end, 0 in Celsius doesn't tell you that much. But in the other scale on Kelvin temperature, 0 degrees Kelvin actually means the absence of temperature. So in that, Kelvin is a good example of a ratio variable. But Celsius is more like an interval variable. In the end, the important thing is that you understand the difference from this scale. Scale, it has, if you have absolute 0, then it's ratio. If you don't have absolute 0, interval. The rank is when the information or the data that you have doesn't tell you how fastest, how faster, older, bigger anything is compared to other observations, because it only tells you which is the largest, the oldest, the biggest, and it just gives you an order. But it is important, the number tells you something. And in nominal variables, it just tells you that it's different things, right? Like 1 means male, 0 means female, and that's it. It doesn't mean that men are valued and women are not. In statistical terms, it is like that. In rhetorics, people argued that that actually affected how we envision gender, and then that's why right now we prefer to use 2 for women and 1 for men, because rhetorically it makes sense that it's kind of rude to say women is 0 rhetorically. So we actually say like it's actually rude, let's put it 2. But in statistical terms, it doesn't mean anything, okay? So be careful on that. Understand these different groups. If you didn't get it at first, watch the video again, maybe look for a few examples, and we're going to do a practice in the lecture, and we'll give you some, because that's a tricky thing. Like sometimes it sounds easy right now, but then when we actually have data, it can be tricky to categorize the variables. So this is how do we categorize variables according to how we measure them. In the next videos, we're going to talk about other ways to categorize variables that are important, but this is the most important, okay? So the other ones are a little bit important.